Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice, Paper 11 from October-November 2018. You can go to any particular question by following timestamps given in the video description. Let's start. Question number 1. The first 4 ionization energies for element X are shown in the table. Which ion of X is produced by removing an electron from a filled shell? In the table we can see different ionization energies are given. This is the first ionization energy, then second, then third and fourth. And we can see that there is a larger difference between third and fourth ionization energy. It means that the fourth electron is closer to the nucleus as compared to the third, second and first one. So from this jump we can assume that the fourth electron is removed from inner shell. Now it means that there are 3 electrons present in the outer shell of the element X. So this is the outer shell. As we know that the inner shell is already complete, if it is the first shell it will consist of 2 electrons, if it is second or any other shell it will consist of 8 electrons. Now removal of first electron will induce +1 charge, then second electron it will become +2 charge, then third electron +3 charge, and now fourth electron is removed from a filled shell, so now the charge will be +4. The answer is therefore D. Question 2. What is the basic assumption of the kinetic theory as applied to an ideal gas? A. Collisions between molecules are elastic. This is a true statement for ideal gas as there is no energy gained or lost among collisions, so the collisions are perfectly elastic. B. Each gas molecule occupies a finite volume. Now according to ideal gas theory, the volume of one gas molecule is almost negligible. It is not finite. So part B is incorrect. C. Gases consist of particles that experience the force of gravity. In ideal gas situation, there is no force of attraction or repulsion between the molecules and between molecules and gravitational force. So therefore this is incorrect. In D again we can see that gas molecules attract each other, so there must be forces of attraction, which is also incorrect for ideal gas. The only correct option is A. Question 3. A sample of hydrocarbon C6H12 is completely burned in dry oxygen and the product gases are collected as shown. Product gases is H2O, CO2 and excess of oxygen. First one is P. We have anhydrous calcium chloride. It is used to absorb H2O vapors. Second part consists of soda lime, which is used to absorb carbon dioxide gas, and excess of oxygen just goes through it. The increase in mass of the collecting vessels P, which is the first one, and Q, which is the second one, are mass of P and mass of Q respectively. What is the ratio MP/MQ? The formula of hydrocarbon is given. It is C6H12. Let's write a balanced equation for its complete combustion. As we have 6 carbon atoms on the right-hand side, so we can balance by writing 6 with CO2. And we have 12 hydrogen atoms, so we can write 6 with H2O to make it 12. Now there are 12 oxygen atoms in carbon dioxide and 6 in water, so in total we have 18 oxygen atoms, so we can write 9 with O2 to make it 18. From balanced equation we can see that 1 mole of this compound is completely burned to form 6 moles of CO2 and 6 moles of H2O. Let's find the masses of the product that is formed. We have 6 moles of CO2. Now mass is equal to moles into molecular mass. Molecular mass of carbon dioxide is 44, 12 for carbon and 32 for oxygen. Number of moles is 6. So 6 into 44, it comes equal to 264 grams. Second is water. We have 6 moles. So again, finding the mass is equal to moles into molecular mass. Molecular mass of water is 18, 16 for oxygen and 2 for hydrogen. So 6 into 18, it comes equal to 108 grams. Now finding the ratio between MP and MQ, we have MP, MQ. Now MP is the mass of water that is absorbed and it is equal to 108 grams. And MQ is the mass of carbon dioxide that is absorbed, which is equal to 264 grams. Now the ratio comes equal to 0.41. Therefore, A is the answer. Question 4. 5 gram samples of carbonates of barium, copper, lithium and magnesium are decomposed to metal oxides and carbon dioxide. For which compound is there the greatest loss in mass? Let's first find the molecular masses of these carbonates and number of moles from this given mass. We have barium carbonate, copper carbonate, lithium carbonate and magnesium carbonate. In one carbonate we have 1 carbon and 3 oxygen. So it comes equal to 60. Now from periodic table we know that the atomic mass of barium is 137.3 plus 60. It comes equal to 197.3. For copper, the atomic mass is 63.5 plus 60, which is carbonate. It comes equal to 123.5. Similarly, we have 2 lithium in lithium carbonate. The atomic mass of 1 lithium is 6.9. So 6.9 into 2 plus carbonate, which is 60. It comes equal to 73.8. For magnesium carbonate, the atomic mass of magnesium is 24.3 plus 60. It is equal to 84.3. Now finding the number of moles, the mass is given, which is 5.0 grams, and the formula is number of moles is equal to mass in grams divided by molecular mass. So for barium carbonate it is equal to 5 divided by 197.3, which is 0.0253. Similarly, for copper carbonate, the number of moles come equal to 5 divided by 123.5, which is equal to 0.04 moles. For lithium carbonate, the number of moles is equal to 0.067 moles. For the last one, we have magnesium carbonate, the number of moles come equal to 0.0593 moles. Let's write the balanced equation for decomposition of carbonates. First one is barium carbonate. Now barium carbonate decomposes into metal oxide, which is barium oxide, along with carbon dioxide gas. The equation is already balanced. So for 1 mole of barium carbonate, we have 1 mole of carbon dioxide and 1 mole of barium oxide. So from given number of moles 0.0253, the number of moles of carbon dioxide will be 0.0253. As carbon dioxide is gas, it will escape. So the mass of carbon dioxide is actually the mass that is lost. So therefore the mass of carbon dioxide is actually the mass that is lost. As we have to find out the greatest loss in mass, so it means that the carbonate that produces most mass of carbon dioxide will be the answer. Now we can convert these moles of carbon dioxide into mass by multiplying with molecular mass of carbon dioxide, which is 44. So the mass of carbon dioxide comes equal to 1.113 grams. Second is copper carbonate. Again we can write the equation. CuCO3 forms copper oxide along with CO2. The equation is balanced, the number of moles are equal, we have 1:1 ratio. So for 0.04 moles of copper carbonate, the moles of carbon dioxide will also be 0.04 moles. Now converting these moles into mass, we can multiply by 44, which is the molecular mass of CO2. So it comes equal to 1.76 grams. So for barium carbonate, the mass lost was 1.113 grams. For copper carbonate, the mass lost is 1.76 grams. Third one is lithium carbonate. It decomposes to lithium oxide and CO2. Again the ratio is 1:1 and the equation is balanced. So for 0.067 moles of carbon dioxide will be same. Converting it into mass, we can multiply by mR of CO2. So it comes equal to 2.948 grams. For last one we have magnesium carbonate. It decomposes to magnesium oxide and carbon dioxide. Again the equation is balanced and the ratio is 1:1. So for 0.0593 moles, the number of moles of CO2 will be same. Converting it into mass by multiplying with 44, it comes equal to 2.60 grams. So we can write 2.948 for lithium carbonate, 2.60 grams for magnesium carbonate. As these are the masses of carbon dioxide, it means that this much mass is lost, as carbon dioxide is gas and it escapes. So therefore the greatest loss in mass is in lithium carbonate. Question number 5. In this question you should assume methane behaves as an ideal gas. The gas laws can be summarized in the ideal gas equation below. PV is equal to nRT. Volume of sample of methane is measured at a temperature of 60 degrees centigrade and a pressure of 103 kilopascals. Volume is 5.37 exponential minus 3 meter cube. What is the mass of sample of methane given to two significant figures? We are going to use the ideal gas equation. For ideal gas equation, the pressure must be in pascals. As we have kilopascals, so it can be converted into pascals by multiplying by 1000. So it will be equal to 103,000 pascals. The volume should be in meter cube as it is already given in meter cube. N is the number of moles and we have to find the mass. The molecular mass of methane as it is CH4. So 12 for carbon and 4 for 4 hydrogen. The molecular mass is 16. So we are going to use the formula moles is equal to mass divided by molecular mass and we can find the mass. R is the ideal gas constant and its value is 8.31 joules per Kelvin per mole. T is the temperature and temperature must be in Kelvin. So we can convert degree centigrade into Kelvin by adding 273. Now we can rewrite the formula. Pressure into volume is equal to number of moles into R into temperature. Pressure into volume is equal to mass divided by molecular mass into R into temperature. Then mass will be equal to pressure into volume into molecular mass divided by R into T. Now putting the values, mass equals pressure. Pressure is 103 kilopascals, so we can write 103,000 pascals into volume, which is 5.37 exponential minus 3 meter cube, into molecular mass of methane, which is 16, divided by value of R, which is 8.31, and temperature, which is in Kelvin, 333. Now by multiplication and division, the mass comes equal to 3.198 grams. As we have to give answer to two significant figures, so it means the first two figures will be used. As 9 is more than 5, so it will be equal to 3.2 grams. The answer is therefore C. Question 6. A butane burner is used to heat water. The molecular mass of butane is 58. Standard enthalpy change of combustion of butane is given. It is -2877 kilojoules per mole. 250 grams of water is heated from 12 degrees centigrade to 100 degrees centigrade. The burner transfers 47% of the heat released from the burning fuel to water. Assume that the butane undergoes complete combustion and none of the water evaporates. What is the minimum mass of butane that must be burnt? The enthalpy change for this reaction can be measured by using formula delta H, which is enthalpy change equals minus mc delta T. Now m is the mass of water that is used, so it is 250 grams. C is the specific heat capacity of water, which is constant. It is equal to 4.18 joules per gram per degree centigrade. Delta T is the change in temperature. As we can see, the temperature has risen from 12 degrees centigrade to 100, so therefore change in temperature will be 88 degree centigrade. So delta T is 88. Let's find the enthalpy change by putting in the values. Mass is 250 grams. C is 4.18. Delta T is 88. So delta H comes equal to minus 91960 joules. Now this is the enthalpy change when the burner transfers 47% of the heat released. So for 100% we can find out the value by using ratio method. So as 91960 is for 47%. So for 100% it will be equal to X. By cross multiplying we can find the enthalpy change for 100%. It comes equal to minus 195,659 joules. Now from the question we already know that the enthalpy change of combustion of butane is minus 2877 kilojoules per mole. And it is when we have molecular mass which is equal to 58. So we can say that 58 grams per mole of butane gives minus 2877 kilojoules, or if we convert it into joules then we can multiply by 1000. So this much energy is given by 58 grams of butane. So for our value minus 195,659 joules we can find the mass by using cross multiplication. So the mass of butane that gives this much energy comes equal to 3.94 grams. Therefore answer is C. Question 7. Nitric acid is known to take part in the oxidation of atmospheric sulfur dioxide. One possible reaction is shown. SO2 reacts with nitric acid to form NO+, HSO4 negative, which row shows the correct changes in oxidation numbers of nitrogen and sulfur. Let's first find out the oxidation states of nitrogen and sulfur in each of the compound. We have SO2, HNO3, NO positive, and HSO4 negative. We have sulfur and 2 oxygen. The oxidation state of 1 oxygen is -2. So for 2 it will be equal to -4. Overall charge is 0. Sulfur is +4. In second one we have 1 hydrogen, which is plus 1 nitrogen, 3 oxygen, overall charge is 0. So nitrogen equals plus 5. In NO plus we have 1 nitrogen, 1 oxygen equals overall charge, which is plus 1. So nitrogen equals plus 3. In HSO4 we have 1 hydrogen, which is plus 1, 1 sulfur. For 4 oxygen the oxidation state will be minus 8, overall charge is minus 1. So sulfur equals plus 6. So for sulfur we can see that the oxidation state has increased from plus 4 to plus 6, so the increase is plus 2. For nitrogen the oxidation state has decreased from plus 5 to plus 3, so the decrease is also minus 2. The answer is therefore B. Question 8. A transition metal ion M plus 2 reacts with acidified dichromate 6 ions to form M plus 4 ions, chromium plus 3 ions and water. Which equation correctly represents this reaction? We can write two half equations. First one is M plus 2, which converts into M plus 4. So it will be M plus 2 forms M plus 4, and this is oxidation. For second equation, which is dichromate converts into chromium plus 3, we can write Cr2O7. The charge is negative 2. It converts into chromium plus 3. Let's find out how many electrons are lost and gained. As M plus 2 converts into M plus 4, it means it has lost 2 electrons. And in Cr2O7 negative 2, we can find the oxidation state of Cr, which is given. It is plus 6. So from plus 6 it goes to plus 3. It means it has gained 3 electrons. Now in balanced equation, the number of electrons lost and gained must be equal. So we can multiply the second equation with 2 to make it 6 electrons, and we can multiply the first equation with 3 to make it 6 electrons. Rewriting first equation, we have 3m plus 2, which gives 3m plus 4 and 6 electrons. Now rewriting the second equation, we have each component multiplied by 2. As we can see that we have 2 chromium on the reactant side and 1 chromium on the product side, so we are going to multiply 2 with just the product, not with this one, as chromium will be balanced. So it will be Cr2O7 negative 2 plus 6 electrons gives 2 Cr plus 3. Now chromium is balanced. Now next step is to balance the number of oxygen atoms, as there is no oxygen in the first equation, so we are going to ignore that one. We have 7 oxygen atoms in the second equation, so we can write 7H2O with the product. Now oxygen is balanced. Now we have 14 hydrogen atoms on the product side, so we can balance that by adding 14H positive. Now combining both these equations, the number of electrons lost and gained will be cancelled out. And the final equation will be Cr2O7 negative 2 plus we have 14H plus. Then we have 3m plus 2. On the product side we have 2 chromium plus 3. 7 water molecules and 3m plus 4 ions. Now this equation is exactly similar to the one given in part C. Question number 9. In this question, you should assume that all gases behave ideally. Hydrogen and iodine react reversibly in the following reaction. The system reaches dynamic equilibrium. This is the equation. The enthalpy change is negative. It means it is exothermic reaction. Which statement must be true for the Kp of this equilibrium to be constant? Before going into the options, you should always remember that Kp or Kc is only changed or only affected by temperature. It is not affected by other things such as concentration, pressure or catalyst. A. The partial pressures of hydrogen, iodine and HI are equal. This does not change Kp or does not make it constant. B. The external pressure is constant. External pressure also does not affect Kp. The forward and reverse reactions have stopped. This is not possible because at equilibrium it is dynamic in nature, in which forward and reverse reactions are continuously occurring. D. The temperature is constant. This is the only option that is true because temperature can affect the value of Kp. So in order to keep Kp constant, the temperature must be constant. The answer is therefore D. Question 10. 0.200 moles of sulfur dioxide and 0.200 moles of oxygen are placed in 1 decimeter cube sealed container. The gases are allowed to react until equilibrium is reached. This is the balanced equation. At equilibrium, there is 0.1 moles of SO3 in the container. What is the value of Kc? We can use the formula. Kc is the concentration of product divided by concentration of reactant. So the product is SO3. For concentration, we use square brackets. Raised to the power its number of moles, which is 2, divided by the concentration of reactant. For first one, we have SO2. Second one is oxygen. Number of moles of SO2 is 2, so it will be power 2. And for oxygen, it will be 1. As volume given is 1 decimeter cube, so number of moles and concentration will be same, as concentration is equal to moles divided by volume. So moles divided by 1 equals the moles. We can write the balanced chemical equation. We have SO2 that reacts with oxygen to form SO3. The number of moles ratio is 2:1:2. Initially, the amount in moles is given. So we can write the initial concentration or initial number of moles of SO2, which is 0.2 moles. Initial moles of oxygen was 0.2 moles. Now at equilibrium we can find out the moles. At equilibrium we can see that 0.1 mole of product is given. So as the ratio is same for SO2 and SO3 according to the balanced equation, so it means for 0.1 mole of SO3, 0.1 mole of SO2 would have reacted. Similarly, for the ratio between SO3 and oxygen, we can see that 1 mole of oxygen makes 2 moles of SO3. So 0.1 mole of SO3 will be formed from half moles of oxygen. So it means 0.05 moles of oxygen has reacted to form this product. Now after equilibrium, the amount left can be calculated. We have 0.2 initial and 0.1 has reacted. Now we can find out the moles that are left behind in the equilibrium. Initially we had 0.2 moles of SO2, 0.1 mole is reacted, so we can subtract these two. So we have 0.1 mole that is left unreacted. Similarly, for oxygen, we can find out the number of moles unreacted by subtracting these two, 0.2 minus 0.05. So we have 0.15 moles of oxygen present at equilibrium. And the amount of SO3 given at equilibrium is 0.1 mole. Now putting these values in the Kc equation, Kc is equal to concentration of SO3, as 0.1 mole divided by 1 equals 0.1. So it is 0.1 raised to the power 2. For SO2 again we have 0.1. For oxygen we have 0.15. So the value of Kc comes equal to 6.67 per mole decimeter cube. The answer is therefore D. Question 11, two reactions are shown. This is the first one, this is the second one. In reaction 1, a finely powdered iron catalyst is used. In reaction 2, a vaporized tetrachloromethane catalyst in UV light is used. Which statement about the catalyst use is correct? A. Both reaction 1 and reaction 2 use a heterogeneous catalyst. B. Both reaction 1 and 2 use a homogeneous catalyst. Now you should remember what is heterogeneous and what is homogeneous. In heterogeneous, the catalyst is in different state as compared to reactants. For example, we can see that in reaction 1, nitrogen is in gas form, hydrogen is in gas form, again ammonia is gaseous, while the catalyst used is iron, which is solid. So it is in different state as compared to the reaction components, so therefore this is heterogeneous catalyst. In second reaction, we can see that vaporized tetrachloromethane, which is CCl4, vaporized means it is in gaseous form, it is used in UV light. So as other components of reaction are also in gaseous state, so therefore this is homogeneous catalyst. So reaction 1 has heterogeneous catalyst while reaction 2 has homogeneous catalyst. The answer is therefore C. Question 12. Sodium and sulfur are burned separately in oxygen. Each reaction has a distinctive colored flame. Which row is correct? First is the flame color of sodium and second is the flame color of sulfur. Now this question is based on the fact, so therefore you should remember that sodium is yellow in flame while sulfur gives blue flame. The answer is therefore C. Question 13. X and Y are elements in period 3 of the periodic table. The oxide of X is solid at room temperature. The oxide has a giant structure. The chloride of X does not react with water. Argon is the only element in period 3 with a lower melting point than Y. What could be the formula of compound form between element X and element Y? The elements in period 3 are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. The oxides formed by these elements that have giant structure are sodium oxide, magnesium oxide, aluminum oxide, silicon dioxide, while the oxide of phosphorus and sulfur have simple molecular structures. These oxides are also solid at room temperature. So X could be sodium, magnesium, aluminum or silicon. Second point is the chloride of X does not react with water. The chloride of sodium is NaCl. For magnesium it is MgCl2. Aluminum chloride is AlCl3. Silicon chloride is SiCl4. Now sodium chloride and magnesium chloride are ionic compounds and they do not react with water, while aluminum chloride and silicon chloride, they do react with water to form acidic solutions. So element X could be sodium or magnesium. Now let's find out which is element Y. The third point says that argon is the only element in period 3 with a lower melting point than Y. It means that Y is also a gas, so therefore it should be chlorine. So the formula between X and Y could be sodium chloride or magnesium chloride. As only sodium chloride is given, the answer is therefore C. Question 14. Which row describes the structure and bonding of SiO2 and SiCl4? In SiO2 we have giant structure because each silicon is bonded directly with 4 oxygen atoms, and each oxygen atom is bonded directly to 4 silicons. Again, one silicon is bonded to 4 oxygen atoms, and this structure continues on and on. Therefore, SiO2 is giant, and the bonding is covalent as electrons are shared between silicon and oxygen. It is not ionic. Now in SiCl4, one silicon atom makes covalent bond with 4 chlorine atoms. And this is a simple molecular structure as it consists of only 5 atoms. The bonding is covalent as electrons are shared. The answer is therefore B. Question 15. A sample of anhydrous calcium nitrate is placed in a test tube and heated in a roaring Bunsen flame until it decomposes. The description of the gas in the test tube is then noted. A glowing splint is then put in the test tube and any changes are noted. Which observations are correct? First observation is related to the description of the gas in test tube. Second is the result of glowing splint test. Let's write the equation for decomposition of calcium nitrate. Calcium nitrate decomposes in heat to form calcium oxide, nitrogen dioxide, and oxygen gas. As calcium nitrate is solid, calcium oxide is solid, NO2 is gas, oxygen is gas. NO2 is the gas that is brown in color. So the description of gas should be brown. Second gas that is formed is oxygen. So for oxygen the glowing splint relights. The answer is therefore B. Question 16. Which row correctly describes the properties of halogens as group 17 is descended from chlorine to iodine? First one is volatility and second is the strength as oxidizing agent. Now we know that descending in group 17 we have chlorine, bromine, iodine. As we move from top to bottom, the state changes from gas to solid. It means that the volatility is decreasing. This is because number of electrons increase and interatomic forces of attraction develop. Second is the strength as oxidizing agent. Now oxidizing agent is the one that can easily take electrons, as we know that chlorine is more electronegative than bromine and bromine is more electronegative than iodine. So therefore strength as oxidizing agent increases upwards. So descending in group 17, the strength of oxidizing agent decreases. The answer is therefore A. Question 17. Reaction 1. Chlorine reacts with cold aqueous sodium hydroxide to form solution Z. Reaction 2. Solution Z is heated to form ClO3 negative and Cl negative aqueous. Which equations represent reaction 1 and reaction 2? Let's write reaction 1. We have chlorine. It reacts with aqueous sodium hydroxide to form products. As it is cold aqueous sodium hydroxide, so the product formed is sodium chloride, sodium chlorate, which is NaClO, and water. Now we can write ionic equation for this reaction. It will be Cl2, sodium aqueous, hydroxide aqueous, sodium chloride, NaClO, and H2O. Now cutting out the spectator ions, we have sodium. The equation that is left behind is Cl2 aqueous plus 2 hydroxide aqueous gives chloride, ClO, and water. Now second reaction is that solution Z is heated to form ClO3 negative and Cl minus. So we can write equation for that one. In solution Z we have ClO negative. It forms ClO3 negative and Cl negative. We can balance this equation. We have 3 atoms of oxygen on the product side, so we can write 3 with Cl. Now we can balance chlorine by writing 2 with Cl negative. As we can see that our first reaction and second reaction is similar to the one given in D, so therefore D is the correct answer. Question 18. Which statement explains the observation that magnesium hydroxide dissolves in aqueous ammonium chloride but not in aqueous sodium chloride? For the reaction of magnesium hydroxide with aqueous ammonium chloride, you should remember that ammonium salt reacts with alkali to form salt, water, and ammonia. In ammonium salt, NH4 positive ions are present, while in alkali, OH negative ions are present. NH4 plus donates its proton to OH negative to make ammonia gas and water. While with sodium chloride, the ammonium salt cannot donate a proton to make water and ammonia, so therefore option D is correct. All other options does not explain this reaction, so therefore answer is D. Question 19. Transition elements and their compounds are widely used as catalysts. What is the identity and what is the oxidation number of the element present in the catalyst used in the contact process? Contact process is for the manufacture of sulfuric acid, and the catalyst that is used in this process is vanadium pentaoxide, which is V2O5. Let's find out the oxidation number of vanadium. We have 2 vanadium atoms, 5 oxygen atoms, and overall charge is 0. For 1 oxygen the oxidation state is -2, so for 5 it will be -10. So 2 vanadium equals +10, or 1 vanadium will be equal to +5. Answer is therefore D. Question 20. What is true for every nucleophile? Nucleophile means nucleus loving. So we can say that any species that has negative charge or lone pair of electrons, it can be considered as nucleophile. A. It attacks a double bond. This is incorrect because double bond is actually electrons and nucleophile does not attract electrons, it is attracted to positive charge. In double bond, pi electrons are present and these pi electrons itself they behave as nucleophile. B. It donates a lone pair of electrons. This is true for nucleophile because nucleophile has lone pair of electrons. For example, we have NH3. It has lone pair of electrons. It can give its electron to form coordinate covalent bond. Similarly, another nucleophile is OH, which can donate its lone pair of electron. C. It is a single atom. This is not always true because we can see that in NH3 we have 4 atoms, in OH we have 2 atoms. D. It is negatively charged. Now this is not always true because it can be neutral. For example, NH3 is neutral. The answer is therefore B. Question 21. X has the molecular formula C5H12O. X has a branched carbon skeleton and a secondary alcohol functional group. How many structural isomers fit in the description of X? Let's draw the branch structure of C5H12O. So we have 5 carbon atoms. 4 carbon atoms are in the long chain while 5th one is as a branch. Now we have secondary alcohol functional group also attached. Secondary alcohol means it is attached with the carbon atom that is directly attached with 2 carbon atoms. So this is the only position for secondary alcohol. Other structures of C5H12O could be like this. Or like this. This is wrong because in this one we don't have a branched carbon skeleton, and this is wrong because now we have tertiary alcohol as compared to secondary alcohol. So the only possible structure is this one. The answer is therefore A. Question 22. A new jet fuel has been produced that is a mixture of different structural isomers of compound Q. This is compound Q. Which skeletal formula represents the structural isomer of Q? Let's first find out the number of atoms present in Q. We have 9 carbon atoms in the long chain and 5 carbon atoms are as substituents. So in total we have 14 carbon atoms. Now let's look at A. We have 9 carbon atoms in the long chain, 5 carbon atoms as substituents. So in total we have 14 carbon atoms. In B we can see that we have 8 carbon atoms in the long chain, while 5 carbon atoms are as substituents. So in total we have 13 carbons. As for isomers, the number of carbon atoms should be same as the formula is same, so therefore B is incorrect. Now in C we can find out the total number of carbon atoms. There are 7 carbon atoms in the long chain, and we have 7 carbon atoms as substituents. So in total we have 14 carbons. Similarly in D we can see that nine carbon atoms are in the long chain and we have 5 carbon atoms as substituents. So 9 and 5 become 14. Let's find out the name of structure A. We have substituents on 2nd, 3rd, 5th, 7th and 8th carbon. In total we have 5 methyl groups, so it is pentamethyl And in long chain we have 9 carbon atoms, so it is nonane. Similarly for D, we can name this. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, 9 carbon atoms. Again we have substituent on second, third, fifth, seventh, eighth. In total we have 5 methyl groups, so it is pentamethyl. And 9 carbon atoms in the long chain, so it is nonane. So we can say that A and D are actually same compounds. Now naming part C, we have 1, 2, 3, 4, 5, 6, 7 carbon atoms in the long chain. Now on second carbon, 4th, 5th and 6th we have methyl groups, so we can write 2, 4, 5, 6. As there are 4, so it is tetramethyl. On third carbon atom we have isopropyl group. And in long chain we have 7 carbon, so it is heptane. Now we can look at the structure. In the given structure we had 1, 2, 3. On second, third, fifth, 7th and 8th we had 5 methyl groups, pentamethyl, and long chain was of 9 carbon, so we can write nonane. So as we can see that A is similar to the one given in the question, similarly D is the same, so C is the only one that is isomer because its structure is different. Question 23. The conversion of propene to propane 2-ol can be carried out in 2 stages represented by the equation shown. In first reaction, alkene is converted into halogenoalkane, iodine is introduced. In second reaction, halogenoalkane is reacted with potassium hydroxide to make alcohol. How can these 2 reactions be described? Reaction 1. In reaction 1 we can see that alkene is adding hydrogen iodide upon double bond and double bond is converted into single bond. There is no other product that is formed, so therefore this is called addition reaction. So it is addition of Hi. In second reaction we can see that OH from potassium hydroxide replaces iodine atom and makes alcohol, while iodine is substituted, so therefore this is substitution. The answer is therefore B. Question 24. An organic molecule W contains 3 carbon atoms. It requires 4.5 molecules of oxygen for complete combustion. What could W be? A is propane. We have CH3, CH2, CH3. B is propanoic acid, CH3, CH2, COOH. C is propanone, CH3CO, CH3. D is propane 1-ol, so we can write CH2OH, CH2, CH3. Let's write the molecular formula of each of these compounds. In A we have propane, so propane is C3H8. In B we have propanoic acid, so it is C3H6O2. In C we have propanone, so the molecular formula is C3H6O. In D we have propane 1-ol, so the formula is C3H8O. In the question we can see that W contains 3 carbon atoms, so each of our compound contains 3 carbon atoms. Now let's write the chemical equation for combustion. CO2 and H2O is formed. The molecules of oxygen are given. It is 4.5 molecules of oxygen, so we can write 4.5 in balanced equation. Let's balance the oxygen atoms. We have 9 oxygen atoms on the reactant side, 2 and 1 on the product side, so we can balance carbon atoms, 3 carbon atoms. Hydrogen atoms will be balanced. Now number of oxygen atoms is 3 to the 6 plus 4, 10. So as we have 9 oxygen atom on the reactant side and 10 on the product side, so therefore A is incorrect. Now let's balance second equation. We have 3 carbon atoms, so we can write 3 with CO2. 6 hydrogen atoms, so we can write 3 with H2O to make it 6. Now we have 9 plus 2, 11 oxygen atom on the reactant side, and 6 plus 3, 9 oxygen atoms on the product side. So as oxygen atoms are not balanced, so B is also incorrect. In C we have 3 carbon atoms, so we can balance by writing 3 with CO2, 6 hydrogens. So 3 can be written with H2O. Now we have 9 plus 1, 10 oxygen atom on the reactant side, 6 with CO2 and 3 with H2O. So in total we have 9 oxygen on the product side. So oxygen is not balanced. Similarly in D we can balance carbon 3, hydrogen we can write 4. Now we have 9 oxygen atom on the reactant side plus 1. Total becomes 10 oxygen atoms, and 6 plus 4 also becomes 10 oxygen. So as this equation is perfectly balanced, so it should be D. The answer is therefore propane 1-ol, which is D. Question 25. Compound J, which is C15H23Br2Cl, is reacted with excess of hot concentrated solution of sodium hydroxide in ethanol. One of the product is X. What could be the skeletal formula of X? Now you should remember that hot concentrated solution of sodium hydroxide in ethanol, it causes elimination reaction. And in elimination reaction, small molecules such as HCl, HBr, they are removed. And after elimination, carbon-carbon single covalent bond converts into carbon-carbon double covalent bond. So alkene is formed. Let's see, in compound J we have this bromine atom, this chlorine atom and this bromine atom that is present. Now adjacent hydrogen are present on this carbon. We have 2 hydrogen atoms. So one can be removed to make alkene, and elimination of HBr will take place. On this carbon atom we do not have any hydrogen, so therefore double bond will not come between these 2 carbons. So as we can see that in A, double bond is given between these 2 carbons, so it is incorrect. Similarly in C, the double bond is given between these 2 carbons, which is incorrect. Secondly, we can see that this carbon atom has 2 hydrogen atoms, so one will be eliminated with bromine to make a double bond between these 2 carbons. And Cl is removed from this carbon, so a hydrogen will be removed from adjacent carbon to make a double bond between these 2 carbon atoms. So we have 3 double bonds, one on this side, one on this side and one on this side. So in the product we can see that one double bond is present between these 2 carbon atoms, one between these 2 carbon and one between these 2. In B this is shown correctly, while in D only one double bond is formed, which is incorrect. So the answer is B. Question 26. Sodium reacts with 1 mole of compound Y to produce 1 mole of hydrogen gas. Which compound could be Y? Let's react these compounds with sodium. As this is alcohol, so it will form alkoxide with sodium and produce hydrogen gas. Now we can balance this equation by writing 0.5 with hydrogen. So now 0.5 moles of hydrogen gas is produced by this compound. As we want 1 mole of hydrogen, so therefore A is incorrect. Similarly, B is also alcohol. So it will form alkoxide with sodium. Again, we can balance this equation by writing 0.5 with hydrogen. So B is also incorrect as half moles of hydrogen is formed. For third reaction, we have carboxylic acid. So metal plus acid gives salt and hydrogen. Salt formed is CH3, CH2, CH2, CO2Na along with hydrogen. Again, by balancing, we can find that only half moles of hydrogen is formed. So C is also incorrect. In D, we have two functional groups. One is alcohol and one is carboxylic acid. So both will react with sodium. First is the reaction with alcohol to form alkoxide. So the product is CH3CHONA. And second product is with carboxylic acid. So instead of CO2H, it will be CO2Na. As one hydrogen is lost from this side, one hydrogen is lost from this side. So H2 molecule is formed. Now equation is already balanced. So we have 1 mole of hydrogen being formed from 1 mole of compound D. So therefore, correct answer is D. Question 27. Which compound shows optical isomerism and gives a positive test with alkaline aqueous iodine? Optical isomerism is shown by those compounds that have chiral carbon. Chiral carbon is the one that is attached with 4 different elements or groups. And alkaline aqueous iodine gives positive result only with those compounds that have CH3 attached with OH carbon or CH3 attached with carbonyl carbon. Let's find out the chiral carbon. In A we have CH3, C double bond O, CH, OH, CH3. As we can see that this carbon is attached with 1 hydrogen atom, 1 OH, 1 CH3 and 1 this group. So this carbon is chiral. So it will give optical isomerism. We can also see that CH3 is attached with carbonyl carbon. So this will also give positive test with alkaline aqueous iodine. So A is the correct option. Now B is CH3, then carbonyl carbon. Then we have CH2, CH2 and OH. As we can see that there is no chiral carbon present because no carbon is making 4 single covalent bonds with different atoms or groups. So therefore B will not give optical isomerism and it is wrong. Then we can see that CH3 is present with carbonyl carbon, so it will give positive result with aqueous alkaline iodine. C is alcohol. We have CH2, OH, then CH with CH3 as substituent, and then we have aldehyde. Now if we can see that this carbon is chiral carbon as it is attached with 1 hydrogen, 1 CH3, this group and this group, so it will give optical isomer. But we can see that there is no CH3 present with OH carbon or carbonyl carbon, so therefore it will not give positive test with alkaline aqueous iodine. Now with the last one we have 2 CH3 attached with carbon. Also OH is attached with this carbon, and we have aldehyde. As we can see that no carbon is attached with 4 different groups, so therefore we don't have optical isomerism. Also we can see that this is tertiary alcohol as OH is attached with this carbon which is directly attached to 3 carbon atoms. So tertiary alcohol does not give positive test with alkaline aqueous iodine. Correct answer is therefore A. Question 28. Ethane dioic acid is reduced using an excess of lithium aluminum hydride LiAlH4. What is the organic product of this reaction? Now you should know that lithium aluminum hydride is a powerful reducing agent and it reduces carboxylic acids back to primary alcohols. Now we can write this reaction. We have ethane dioic acid, so we have two carboxylic acid functional groups present. It is reduced by lithium aluminum hydride, which gives hydrogen atoms. Both carboxylic acids will be reduced to primary alcohols. So we have alcohol on one side, alcohol on the other side, and water molecule is formed. As two water molecules are formed, so therefore we need 8 hydrogen atoms for this reduction. Now we can find out the name of product. We have 1 carbon, 2 carbon atoms, so it is ethane. And on first carbon atom we have OH, and on second carbon we also have OH, so it is ethane 1,2-diol. Di means 2 and ol means it is alcohol. In B we can see that it is ethane 1,2-diol, so therefore B is the correct answer. Question 29. The dye ester shown can be hydrolyzed by heating with an excess of aqueous sodium hydroxide. What would the products of this reaction be? In hydrolysis of ester, you should always remember that the carbon-oxygen bond between carbonyl carbon and oxygen is always broken. Similarly, this bond will be broken, and now the part having carbonyl carbon will become acid, while the part containing the oxygen atom will become alcohol. Again, the part having carbonyl carbon will become acid. Now we can draw the structure of acid formed. So it is HC double bond O. It should be OH, but as it is aqueous sodium hydroxide, so it will be ONA. Sodium salt of carboxylic acid is formed. The central product will be alcohol. We have 3 carbon atoms in the center. And on both sides we have OH functional group. Similarly, on this side we also have carboxylic acid CH3COOH, which can be drawn like this. Instead of OH, as we have sodium hydroxide, so it will be ONA. In A we can see that they have made carboxylic acid, not sodium salt, so A and B are incorrect. In C and D they have made sodium salt of carboxylic acid, which is correct. Central one is alcohol. This is also sodium salt of carboxylic acid, while in this one they have converted alcohol into sodium salt, which is incorrect. Correct answer is therefore C. Question 30. J is a branched chain alcohol. The formula is C5H12O. J is heated under reflux with an excess of dichromate acidic until no further reaction occurs. An organic compound K is formed in good yield. The infrared spectrum of K is shown. What are the structures of the branched chain alcohol J and compound K? First point is that J is a branched chain alcohol. Now if it is primary alcohol, then it will be oxidized by reflux to form carboxylic acid. If it is secondary alcohol, it will be oxidized to ketones. And tertiary alcohol does not oxidize. Let's draw the structures of J. First one is CH3, CH, it is primary alcohol, so it should be oxidized to carboxylic acid. In K we have this structure, so we can write CH3, CH, CH3, CH2, and then aldehyde is given. Now this is incorrect because in reflux aldehyde is not formed, carboxylic acid is formed. So A is incorrect. Let's draw the structure of B. We have CH3, CH2, CH, OH, CH2, CH3. Now this is secondary alcohol and it will be oxidized to ketone. The product given is this one, CH3, CH2, carbonyl carbon, CH2, CH3. Now as we can see that J is not branched chain, it is straight chain alcohol, so therefore B is also incorrect. Now doing the same for C, we have CH3, CH, CH3. This is secondary alcohol and it should be oxidized to ketone. The structure is this one. As J is branched and K is the correct product, so it could be C. Similarly, looking at D, we have CH3, CH, now this is primary alcohol and it should be oxidized to carboxylic acid. So the product formed is this one. Now as we can see that J is branched chain alcohol, this is true, and K is the correct product from primary alcohol to carboxylic acid, this is also true, so it could be D. Now let's differentiate between C and D on the basis of spectra. In C we have ketone, in D we have carboxylic acid. This is the spectra and we can see that this is a very strong peak and this is of carbonyl carbon, which is between 1670 to 1750. And from this carbonyl carbon you can find out that it can be aldehyde or ketone or carboxylic acid. So as we have ketone and carboxylic acid, so both will show this peak. Second peak is this one, which is of carbon hydrogen bond and it is at about 2950. So again this is also present in both ketone and carboxylic acid. Now for carboxylic acid another peak must also be present, which is OH bond peak, and it should be between 2500 to 3000 and it is sharp and very broad. As we can see that between 2500 to 3000 a sharp and very broad peak is absent, so therefore it is not carboxylic acid, it is ketone. The answer is therefore C, because C gave ketone and D gave carboxylic acid. Question 31. Which ions contain one or more unpaired electrons? Different elements are given. We have copper, manganese and vanadium. Now from periodic table we can find out the atomic number. For copper it is 29. For manganese the atomic number is 25. For vanadium it is 23. Let's first do the electronic configuration for neutral copper. We have copper 29, the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. Now we have 18 electrons. Then we have 3d and 4s orbital. As we know that 4s is filled first, then 3d. So as we can see that 11 electrons are left, as we have 29 total electrons. So 2 should be in s orbital and 9 should be in d orbital. But this is incorrect because 3d subshell is more stable when it is fully filled and half filled rather than partially filled. So what will happen that one electron will move from 4s to 3d. So the electronic configuration will be 3d10, 4s1. This is for neutral copper. Now as we have +2 charge, it means 2 electrons will be lost. Now the loss of electron takes place in such a way that 4s loses electrons first, then electron is lost from 3d. So 3d will become 9 and 4s will become 0. As in 3d we have 5 subshells, 3dxy, 3dyz, 3dxz, 3dx square y square and 3dz square. Each orbital consists of 2 electrons. In total we have 9 electrons. So first we will be filling unpaired electrons and then pairing starts. Now we can see that one unpaired electron is left, so therefore copper +2 is correct. Second is manganese. The atomic number of neutral manganese is 25. So first doing electronic configuration for neutral manganese. This will be equal to 18 electrons. Now we have 7 electrons left. 2 electrons will be in 4s and 5 electrons in 3d. Now the charge on manganese is +3. It means 3 electrons are lost. 2 electrons will be lost from 4s and 1 from 3d. So it will become 3d4, 4s0. 3d4 means that there are 4 unpaired electrons in 3d orbital. So option 2 is also correct. Moving toward third one, we have vanadium, which is 23 in neutral form. So this equals 18 electrons. And then we have 5 electrons left. So 2 in 4s and 3 in 3d. As the charge is +3, it means 3 electrons are lost. 2 will be lost from 4s and 1 from 3d. So it will become 3d2, 4s0. As there are 2 electrons in 3d, so both will be unpaired. So 3 is also correct. As all options are correct, the answer is therefore A. Question 32. Which molecules and ions have a bond angle of 120 degrees? 1. We have BF3. Now we know that boron is having 3 electrons in the outermost shell and it makes 3 single covalent bond with fluorine atoms. So as we have only 3 bonds with the central atom, so the bond angle is 120 degrees. So 1 is correct. 2 is CH3 negative. Now carbon has 4 electrons in the outermost shell and there are 3 hydrogen atoms. So each hydrogen atom is making single covalent bond with carbon. We also have a negative charge, which means extra electron is present. Now there are 3 bond pairs and 1 lone pair is present. The repulsion due to lone pair is greater, so therefore bond angle will reduce and it will get similar to that of ammonia. So 2 is incorrect. Third one is NH3. Again in nitrogen we have 5 electrons in the outermost shell, out of which 3 electrons make single covalent bond with hydrogen atoms, while 1 pair is present in the form of lone pair. The bond angle will be 107. So 3 is also incorrect. As only option 1 is correct, the answer is therefore D. Question 33. Which statements are correct for all exothermic reactions? Number 1. Enthalpy change for the reaction is negative. This is true statement because in exothermic reaction, products have lower energy as compared to reactants. As enthalpy change is equal to energy of product minus energy of reactant. So as product energy is less than reactant, so therefore it will always be negative. 2. On a reaction pathway diagram, the products are shown lower than the reactants. This is true because the energy of product is less than the energy of reactant. 3. The reaction will occur without heating. Now this statement is not true for all exothermic reactions because let's suppose we have combustion of methane. It is an exothermic reaction and we need a spark to start this chemical reaction. So this is not true for all exothermic reactions, so therefore 3 is incorrect. As option 1 and 2 are correct, the answer is therefore B. Question 34. The factors affecting the rate of reaction between aqueous sodium thiosulfate and hydrochloric acid can be investigated. The ionic equation for the reaction is shown. This is the ionic equation. Which of the following can be used to investigate the rate of this reaction? Number 1. The change of mass. As we can see that the state of reactants and product is solid, liquid and aqueous. There is no gas formed, so it means there is no change of mass. So therefore we cannot find the rate of reaction by using change of mass. 2. Change of appearance caused by formation of precipitate. As we can see that sulfur solid has formed from 2 aqueous reactants and sulfur is pale yellow precipitate. So this observation can be used to predict the rate of this reaction by using time. So 2 is correct. 3. Change of electrical conductivity. As we can see that on the reactant side we have ions present, while on the product side no ions are present. It means that electrical conductivity will decrease with time. So we can also find the rate of this reaction by finding out the electrical conductivity at different steps. As option 2 and 3 are correct, the answer is therefore C. Question 35. Which reaction routes can be used to make a pure sample of barium sulfate? First we have barium metal. It is heated in the presence of oxygen to make product. The product will be barium oxide. Then it is put in dilute hydrochloric acid. Barium oxide reacts with hydrochloric acid to form barium chloride. Then it is diluted with sulfuric acid, so it forms barium sulfate. Now barium sulfate is an insoluble substance. It can be filtered, washed and dried to obtain pure sample of barium sulfate. So this process is correct. Second, we have barium nitrate, which is strongly heated in air. Now nitrates heat in air to form oxide, nitrogen dioxide and oxygen gas. So the product is barium oxide, which is solid. Then excess of water is added as barium oxide is soluble in water, so it forms barium hydroxide, which is alkaline. Now barium hydroxide will react with sulfuric acid to form barium sulfate. Again barium sulfate is solid, insoluble. It can be filtered, washed and dried. So this process is also correct. 3. Barium hydroxide is diluted with nitric acid. As it is acid-alkali reaction, the product will be barium nitrate. Then dilute sulfuric acid is added and barium sulfate will be formed, which is solid, insoluble. It can be filtered, washed and dried as no other insoluble substance is present. So this process is also correct. As all 3 options are correct, the answer is therefore A. Question 36. Which properties increase from magnesium to barium? Both elements magnesium and barium are present in the same group. We have magnesium, calcium, strontium, barium. First point is that ionic radius of cation M+2 increases. As we can see that in every period successive shell is added, so it means that the size of cation will also increase as the number of shells increase. So 1 is correct. 2. Screening of outermost electrons by inner shells also increase. As screening depends on the number of shells between nucleus and outermost electron, as we can see that the number of shells increase as we move down in the group, so therefore screening will also increase. 3. Solubility of hydroxides in water. Now we can say that magnesium hydroxide is less soluble in water as compared to barium hydroxide. This is because solubility of group 2 increases down the group. So third part is also correct. As all three options are correct, the answer is therefore A. Question 37. 2-methylpropene can react in more than one way with chlorine. One of the reactions follow the pathway shown. We can see 2-methylpropene reacts with chlorine to form carbocation and chloride, and then we have alkene product which is formed. Which statement about this mechanism are correct? Number 1. The intermediate has all carbon atoms in the same plane. This is the intermediate, and we can see that carbon atom is making 3 other covalent bonds with 3 carbon atoms. So when we have 3 single covalent bonds present, the molecule is planar as it is trigonal. And the bond angle is 120 degrees. So 1 is correct. If carbon was making 4 single covalent bonds, then it would be tetrahedral, which is not planar. Option 2. There is an electrophilic attack on the double bond. Now we can see that in double bond pi electrons are present. What happens that these pi electrons will induce a charge on this chlorine atom by a repulsion of electrons. So these pi electrons make this partial positive and partial negative. As pi electrons are electrophile, so therefore statement 2 is correct. 3. It is a free radical mechanism. Now this is incorrect because no free radical is formed on the reactants as no UV light is present. In free radicals, chlorine free radicals would be formed. As option 1 and 2 only are correct, the answer is therefore B. Question 38. The halogenoalkanes listed below all react with sodium hydroxide, which reactions proceed mainly by an SN1 mechanism. Now you should know that SN1 mechanism is followed by tertiary halogenoalkanes. Let's find out which one is tertiary. First one is 1-iodopropane. So we have 3 carbon atoms in the long chain as it is propane, and iodine is present on first carbon atom. As we can see that the carbon atom attached with iodine is directly attached with just 1 carbon atom, so therefore it is primary halogenoalkane. So 1 is incorrect. 2 is 2-iodo-2-methylpropane. Again we have 3 carbon atoms in the long chain as it is propane. On second carbon we have iodo, and on second carbon we also have methyl group, so it is iodo and methyl. As iodine is attached with the carbon atom which is directly attached to 3 other carbon atoms, so therefore this is tertiary halogenoalkane. So this will go through SN1 mechanism. Third one is 2-bromo-2-methylbutane. As it is butane, so we have 4 carbon atoms in the long chain. On second carbon atom we have bromo, and on second we also have methyl group. Again you can see that the carbon atom attached with bromine is directly attached with 3 other carbon atoms, so therefore this is also tertiary halogenoalkane. So it will go through SN1 mechanism. As option 2 and 3 are correct, the answer is therefore C. Question 39. 3-oxobutanoic acid can be synthesized in a two-step process. In 3-oxobutanoic acid, we have this ketone functional group and this is carboxylic acid functional group. What could be the structure of X? In 1, we can see that compound is given that has alkene and alcohol functional group present. Now alcohol can be converted into carboxylic acid by oxidation. As this is primary alcohol because it is attached with the carbon atom which is directly attached to one carbon only. So therefore oxidation of this alcohol in reflux will result in the formation of carboxylic acid. Second is alkene. Now we cannot break alkene because this compound is of 4 carbon atom and the product is also of 4 carbon atom. So oxidative cleavage of alkene cannot happen. There is though another process in which we can add water, H2O, in such a way that hydrogen atom attaches with the first carbon atom and OH attaches with the second carbon atom. So then it will become secondary alcohol which can be oxidized to ketone. So we will take this alkene, we will do hydration in the presence of acids such as phosphoric acid. What will happen that according to Markovnikov rule, hydrogen will be attached to this carbon atom and OH will attach to this carbon. Now in next step we are going to oxidize. So what will happen that secondary alcohol will convert into ketone and primary alcohol will convert into carboxylic acid. So 1 is correct. In second, we can see that we already have carboxylic acid, so there is no need for changing this part. Again, we can see we have chlorine atom present. Now chlorine can be replaced by OH by using aqueous sodium hydroxide. Nucleophilic substitution reaction will take place and OH will replace Cl to form this product. Again, we can now oxidize this secondary alcohol to ketone. So 2 is also correct. In third one, we have aldehyde functional group. Aldehyde can be oxidized to carboxylic acid. And again, we have halogenoalkane which can be converted into alcohol by aqueous sodium hydroxide. By substitution reaction, OH will replace Br and secondary alcohol is formed. Second part is aldehyde. Upon oxidation, secondary alcohol will convert into ketone, while aldehyde will convert into carboxylic acid. So this is also correct. As all three options are correct, the answer is therefore A. Question 40. Ethanol reacts with HCN in the presence of potassium cyanide. Which changes in bonding occur during this reaction? Now the reaction of ethanol with HCN occurs in such a way that ethanol, which is aldehyde, it has partial positive carbon, partial negative oxygen. Now cyanide from KCN, which is Cn-, it has lone pair of electrons. So it will attack this partial positive carbon by the help of lone pairs. This bond will break and the product formed is CH3C, Cn is attached. And now this bond becomes single, oxygen becomes negatively charged. Now this oxygen will attack hydrogen atom from HCN and this bond is broken. Now the product formed is CH3C, OH, Cn, H, and this Cn becomes separated. 1. A carbon-carbon bond is formed, as we can see that this new bond is formed between carbon and CN, so 1 is correct. Number 2. A carbon-hydrogen bond is broken, as we can see that the bond between this carbon and hydrogen is being broken, so therefore 2 is also correct. 3. A carbon-nitrogen bond is broken. This is incorrect because carbon-nitrogen bond is not broken. As option 1 and 2 are correct, the answer is therefore B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.